But, so this was great, right? But when you ask developers out there what they think about JPMS and what are the different experiences, we have a mixed bag here. And these are some of the reactions that people have had. So one of them is that, well, JPMS only allows you to have one version of a module. As a matter of fact, the JPMS specification doesn't say anything about versions. Modules, as we see them in Java, are on version. Also, you are not allowed to add modules at runtime. You're supposed to compose your modules during the bootstrap and off you go. You have to modularize all your dependencies in order to reap the benefits of JPMS. So that was kind of like an early decision when Java 9 was coming out, is that you either have everything that is modularized or not. So they added a stopgap solution, which is in your manifest, when you create your libraries or you package your code, you can add a manifest entry called automatic module name. And at least you can say this jar provides such module. But you cannot say, I also export these packages or export certain services. This is what you must do with the module info. And there is another option if you do not use the auto module info name in the manifest, that the JVM will calculate automatic module for you, whether you like it or not. But at least you don't have to eat the whole elephant if you want to jump into the platform module system. It is also hard to map dependency coordinates to module dependencies because, again, the JPMS specification doesn't say anything about how you package a particular module. Right now, it's a convenience that we have one module per jar. And Christianstein, which is in the call, he has a list of modules available in Maven Central. He just said that the current list is about 7,700 modules so far in different stages within automatic modules by the JVM, explicit automatic modules in the manifest, or real modules that use the module info. And well, there's another problem is that if you have packages that are not exported, they may collide with different modules again, because we have a mix of real modules versus halfway modules versus not real modules. So if this sounds like something you have heard before, it's probably because of this. This is a specification in the standard that came out many years ago that promised to deliver a module system for Java applications. And it kind of does, but this talk is not about OSGI. This talk is about JPMS. So I don't know if you know, especially I didn't know until I followed Gunnar, is that there is a thing called layers in the Java platform module system. And we can use these layers, we can leverage these layers to fix some of the issues that we just described. There is this class called the model layer. You can see the link is in the Java SE 15, but it's available since, it should be available since Java 9. And basically what the layer allows you to do is construct a class loader that does all the definitions, that had all the modules that you want for executing your program. So here's an example of the standard model layer API coming from the JDK. So you get a hold of a class loader. It will be typically the existing class loader if you want to get started. And then you define paths to two modules. Now, you, again, assuming that we had a one-to-one mapping within one artifact at one module, then we have two jars like this. Then we create some sort of configuration. This is something that the module layer requires. And this is how we specify, given the locations to those jars, what are the names of the modules that we want, and then just put it up, create a module layer, and from the module layer, you can load classes. That's basically it. Now, this is the low-level API that anybody has access to. Let's say, for example, that you have an application like this, and we're going to assume, well, this will be the kind of like the jar coordinates or the gap coordinates for a particular artifact. So we have the group ID, the artifact ID, and the version number. So we have an application that depends on two modules, foo and bar. Both of them depend on log4j version 2.13.1. But notice that foo and bar, they depend on the same greeter module, but different version. And because, well, these are difference in major versions, we might expect there is some breaking compatibilities here. Now, this is something that we encounter every single day of our lives. There's no way that we will be able to make sure that all our dependencies converge. There's always something that is leaking out. So can we do something about this? Yes, we can. And that's why Layrry exists. And Layrry was created by Gunnar, which is also joining us today. He has started the project around, well, he made the first announcements in March of this year, right about the time the pandemic was raging on. And that's about the time also I discovered the program, the project. And there's a funny bit that I'm going to say in just a moment about that. So when he announced the project, he said, well, what if we will have some sort of programmatic API like this one that would allow you to construct the different layers using artifact coordinates or the gap coordinates, so that instead of using the API that you saw earlier that is, again, low level, you have something that is more friendlier here. So what we're seeing here is we're creating a layer for our logging instructions. So we have 3 artifacts for the log layer, and then we have the full layer. This is the representation of the graph that we saw earlier. There's the full layer that depends on log and has a dependency on the greater 100 module. Then we have another layer called bar, which also depends on log, has a dependency on greater 200. And then we have the app layer, which is the one that depends on both foo and bar and whatever else that the app requires. And then we just run the main class that we expect coming from the app. So that main class is somewhere down in that layer structure, but it's because we're able to separate the different active facing layers, and that foo and bar are in isolation from one another, so they can work even if they have conflicting artifact dependencies. So basically, oh, what's going on here? There. So basically, Layrry is an abstraction on top of JPMS. And what you just saw is just the tip of the iceberg, because JPMS has lots to offer. So once that we have seen how Layrry could be used to define modules and bootstrap an application, the next thing we have to think about is, how do we launch these applications? Sure, you can use a programmatic API, define a series of layers, and then just run the layer. I mean, you can at any time create your own launches, but given that the definitions of these modules are maybe the way that we put them together are so direct, and they will always be very similar to one another, it makes sense for Layrry to offer a common way to launch these things. And that's why Layrry is able to read configuration files. And in this case, we have something that is based on YAML. And this is the reason why I got involved into the project, because as Bruno says, YAML is not good. Now, the only problem that I have with YAML is significant white space. But in any case, you can see this is pretty much the same configuration that we saw earlier with the programmatic API. Now, this will allow you to externalize the definitions of the modules, so you can run your application with different configurations without having to change the code. Just, oh, you need a different version for the greeter? Just put it there. Do you need an additional module for the log configuration? Just add it there and just run again. You don't need to recompile. That's the advantage. Now, if you're like Bruno, and if you don't like YAML, well, let me tell you that we have options. So Layrry not only supports YAML, it also supports TOML. And by the way, it has a configuration API that is exposed for anybody to implement in case that you don't like YAML and you don't like TOML, that's fine. You can provide your own configuration mechanism on top of what Layrry does. So you might want to use JSON, XML, or something else. Just go ahead. You just have to hook it up your specific configuration reader, and off you go. Layrry will be just happy constructing the layers for you. Now, this so far that we have seen takes care of assembling the modules, but it will still do just this at one time, and you are not able to load modules at runtime in dynamic way. For this reason, Layrry adds a plugin option. There is one class, there's actually a service class that will be loaded by Layrry using the service loader interface. So if you implement this interface, the plugin lifecycle listener, then you have access to two events, when a plugin is added and when a plugin is removed. The plugin descriptor is it's just how Layrry identifies your additions. I'm going to show our code in just a moment. Now, when you write your own custom plugin lifecycle, you may do something like this. So my service is your custom class that is specific to your application. You use the service loader, not also detect OS specific properties as defined by the Maven OS plugin. So if you're familiar with that one, it will be you will get all the properties for the arch, the name, the operating system, classifiers, and whatnot. Everything is right there. This particular example showcases a JavaFX application. And JavaFX has an additional classifier, or in this case, we call it the OS detected JFX name, that matches the actual jar, the actual module, well, actually the actual artifact that required for JavaFX. And the other properties, like JavaFX version, project, Layrry, and tiles, are supplied by a secondary file. It's just a properties file. It could contain anything you want. It's just a regular properties file again. And when you pass these flags to Layrry, like this, like the Layrry launcher, then it will assemble the layers and launch your application. So now if I can find where my mouse is, I can show you a quick demo. All right, so let's jump into the terminal. And this is the JavaFX application using the similar layers configuration. Let me show you here, layers TOML. So we have a JavaFX layer that defines all the dependencies of the modules for running JavaFX. Then we have a core layer. This is the one that defines the basic types for our application and dependencies such as style effects for displaying some really nice UI elements. And finally, there is this plugins layer. Now, the name could be anything you want to, but notice that instead of defining modules, it defines a path to a directory. This is a relative path to the layers config file. It could also be an absolute directory if you want to. And finally, the main class. Right. I have everything set up for, this actually should be in staging like this. Everything's set up here in this particular directory. So here's the layers configuration file, the versions properties as we saw before, and the plugins directory where dynamic plugins will be loaded from. Now there's nothing there yet here. I'm going to copy this one by one and you'll see what's going on as we go. So I'm going to launch Layrry in just a moment, like this. So Layrry passes the layers config file and the version properties. And the window appears on the second screen. So here it is. So this is modular tiles effects. There's nothing here. So now notice what happens when I copy from staging plugins prepare. And let's copy the clock plugin into staging plugins. Boom. There's a clock right there. And it matches the time and the date so you know that this thing is live. Now let's copy everything, including the clock plugin that we just copied. So we do it like this. And we have two more things. Now we can remove one of them if you want to, like plugins prepare, and then let's remove the couch, the one in the middle. Whoop, that's not it. We should do a ref. Hold on a second, something out happened. Did I break it? Oh, sorry. Oh my goodness. I
You
deleted
remove
from the
it
wrong
from the
directory.
prepared, yeah.
Yeah, exactly. Okay, easy. Staging, plugins, tail. I can do that back. And there we go. It's gone. So yay, it's working. Now, here's the funny thing is that yesterday Gunnar was having a look at this particular application. And there's one additional thing that Layrry does is that for every plugin that is added and remove it, Layrry will output JFR events. So there was a tiny memory leak problem with this application, and it's thanks to Layrry and JFR that Gunnar was able to locate the problem, and we fixed the problem before we did the presentation today. And well, that's the application, but how does the code look like? Quickly, here we go. Here's the main class. This is the only thing that we need. And the main class has a module info that says something like this. There's the module name of the class, main app, exports that package and requires all these things and uses a tile plugin. What is a tile plugin? Tile plugin comes from the core. Here's the module here. And it's just an interface. And this is the interface that defines the tiles that we're going to add or remove to our application. Here's our plugin lifecycle listener. This is the one that is going to be registered and read by Layrry because of that type, plugin lifecycle. Notice that it grabs a reference to the plugin layer, then uses the service loader using that layer to find out if there are any tile plugins available. And if they are, it will add it to a plugin registry. And when a plugin is removed like this, then it will remove it from the plugin registry. If we look at what this thing is doing, it's basically this. And now here's a special trick just for JavaFX, because everything that is UI, this is a rule that should not be broken. Everything that is UI must run inside the UI thread, and everything that is not must run in a different thread. So when Layrry is booting up your application, it will assemble all the modules and it will assemble the plugins if there are any. And when that happens, Layrry is still not running in the UI thread. Because of this, we know that if there is no context, this is specific to the application, then we'll add it to a list of deferred plugins and just put it on a waiting list. But if this register happens at runtime when we just create or just added a plugin, then it will create the UI object and register, and we'll do the right thing. When we remove a plugin from the directory, then this is the code that happens. And at the end, we perform some cleanup and unregisters the plugin from the plugin registry. And if we go back to the main layer, you will notice that after we have created the UI, then the plugin registry will initialize any deferred plugins that were seen during the boot process of the application. So just to recap, this is your entry point to Layrry to figure out if there is a new plugin or if something has been removed. After this is kind of like the similar code that you always do using the service loader, but what is inside here, this is specific to your application. For this one, for JavaFX, what we want to do is just create a UI widget and register into a container. And when the plugin is removed, what this thing going to do is also remove the UI widget from the UI container and just let it go. All right, let's go back to the slides. So we have a few options for launching. We have the command line using the Layrry launcher jar. You can always build your custom launcher using the Layrry API, or if you want to give it a try, you can use JBank to launch your Layrry powered application. So what JBank does is it's a way for you to bootstrap Java as a scripting option, and it has many options for you to define where is the script. In this case, we're telling JBank to download or to use Layrry from the Moditech GitHub organization. This is called a JBank catalog. And the other two parameters is the same parameters that we saw when we launched it on the command line. So what may be coming in the future? These are some of the things that are unknown. We're still playing with ideas, and some of the things may happen before 1.0. So this may happen after 1.0. And in this, we are counting with feedback from the community, from the users, to see what features make sense and how we can make everything to interact together. Because one of the options could be is that what if the configuration files were available in a remote location? So you have Layrry, the Layrry launcher on your local file system, but your launch configuration is somewhere else. It may be inside your organization, in an internet server, or it may be on Twitter, on GitHub, whatever, what have you. And what we want is just be able to launch an application. We will also make sure that you have ready-made binary distributions, such as, so you're able to download that zip file and you get all the instructions and everything ready instead of just referencing the launcher jar. We'll have different distribution channels. I mean, for sure, we're going to host it on GitHub releases, maybe available in Homebrew or some other package manager. SDK man is another thing that we're looking at because, well, it's very friendly for distributing zip files for this kind of launching applications. Now, Gunnar wrote a couple of blog posts on when Layrry was launched. The first is the inaugural announcement for Layrry and the reasons of being for Layrry, some of the reasons I explained today, but he, of course, does a much better job explaining why Layrry is as it is today. And the second blog post showcases the plugin system as you saw today, but instead of JavaFX, he shows it with Vertex. So the plugin system is not specific to JavaFX. It's pretty much you can use it with any kind of application where you want to have a runtime behavior added or remove it. Then the next link is the website for the repository for Layrry. The JavaFX example is available on the fourth link, and we'll be adding more examples to that repository. So everything that we saw today is open source. And, you're more than welcome to contribute, to give us feedback. If you haven't contributed to open source before, let me tell you, it's quite easy. You find a problem with anything that we saw today or anything else, just file a ticket. That's it. You don't have to send code. Just let us know that something is wrong, or maybe there is a missing feature. But if you have the time and you want to help us with code and sending test cases or just getting to contribution, sure, we are more than happy to welcome you. So I think this is all that I have right now. Matthias told me that I should spend 30 minutes, otherwise he will hang me. So I think I'm pretty much on time. So I'll open the floor for any questions that you may have.
Yes, let's start with some questions. We are not that many, so I guess we can just shout it out. Otherwise, I don't know if you see the hand signal thing. I, as a host, don't see it anyway. I'm not sure that I put it on with Zoom, but let's open for comments and questions and journal discussion. Maybe Gunnar want to go first.
I mean, all I can say is thanks so much, Andres. Awesome job. This was really very well done. Thank you so much.
Okay, I just have to say that I'm always nervous before a session, but it's one extra level to have the creator of the tool in attendance.
I try to behave.
So there's a question from Christian that says, perhaps, so apparently lightweight Java gaming library, so LWJGL, I think, if I mispronounce it, do they use a different OS classifier as well?
Yeah, I think so. Right? I mean, I'm not totally sure, but I think those values like Linux, macOS, Windows is not what the Maven standard, whatever labels are. So
is
I believe
there a Maven standard?
I thought, Andres, you must help me out. I thought there was like at least a convention or something which is shared by a few Maven plugins or dependencies.
Yes, exactly. Both the Maven and Gradle OS plugins use the same conventions, but it may be the case that, we saw JavaFX uses different conventions for the classifier, and I was not aware that Lightweight Juggle also uses different conventions. We'll probably have to see with what is this 3D library? Was it Monkey something?
Yes, they built upon this platform. Yeah.
I see.
Monkey,
Okay.
Monkey gaming library engine, whatever. Monkey engine. JMonkey engine. Yeah.
JMonkey engine, exactly. We'll probably have to have a look at these other classifiers. But the thing is that even if we do not support these classifiers from out of the box from Layrry, if you pass an additional properties files, you will still be able to do this. Now, there is no conditional way to switch one classifier to the other. You will have to build your own custom runner for this if it's not supported by Layrry out of the box.
Okay.
But Christian, you know the open source drill, right? Just in the PR and it will happen.
Yeah, of course. I change a character or two, maybe.
And that brings me exactly how I got involved into this project. When I saw Layrry announce in March, I was quite excited by what I saw, but I wasn't really happy because they chose, so Gunnar decided to go with YAML, I guess. Well, YAML is everywhere right now, whether we like it or not. It's like XML from 10 years ago, I guess. And my first comment is a nice thing, but lose the YAML, use something else. And that's exactly what Gunnar said. Yeah, sure, why not? PR is welcome. And guess what? That's exactly what I did. And that's how I got involved with Layrry.
That was the idea, just to add something annoying so people like you would be motivated to contribute.
Okay. Helena, do you have any questions?
No, I have no questions. This is a little bit out of my league, but I'm going to look into it a little bit when I.
Yeah, so I'm kind of wondering why Andres was so excited in March when it was released. I mean,
exactly. I'm about to say this. So Java 9 came out almost 4 years ago. And everybody was excited about the things that were coming in 9. But if you really want to take advantage of the module system, you have to switch all the way. And as we saw earlier, there are some roadblocks, there are some issues that need to be sorted out. And because of these reasons, there are not that many people that have switched to Java 9 Plus. They are still on Java 8. They are still running on the class path. And for those of us that have switched to Java 9 or greater, we are still not running modular applications for, again, some of those reasons. But Layrry removes some of these obstacles. And that makes me very, very excited, because before I had to figure out how to deal with versioning, how to deal with incompatible packages, how to deal with, do I have to create shaded artifacts? I didn't know exactly what to do. And the tooling, both Maven and Gradle were not ready. Today, Maven already offers much more options for creating modular applications. Gradle is still there. And I know, Christian, you want to say something about Bag, another build tool that it's the design for Bag is just do modules. So we are now 4 years later at a stage where the tooling space has